This is a past exam paper from 2016 on speed and acceleration. Right, let's read the question and let's see what we have to do. In a soapbox competition, a driver raced against the clock in a straight line down a track in a vehicle with no power source. The table below gives the distances from the start travelled by the driver at various times during a run down the track. Okay, so we can see at time 0, so at the very beginning of the race, the car hadn't travelled anywhere. Now we've got the time going all the way from 0 seconds up to 20 seconds, and the distance going from 0 meters all the way up to 100 meters. Right, part 1. Use this table to draw a distance against time graph. So when we're talking about this table, that's the one right there. Okay. So we just have to plot our points. So first point is time is 0 and distance is 0. Now they've made this kind of somewhat easier on us. They have labeled our axes for us, okay, time and distance, and they've given us our scale as well. Now, first point is 0 and 0. So there's 0 seconds and 0 distance. Okay, so I need my pen. We shall go for red. Okay, so that is our first point right there. Next point. Time is 4 seconds and the distance is 6 meters. Okay, so we know we're going to be at 4 seconds, which is that one right there. And now we need to find out where is 6 meters on this. So have a look closely at the scale, at the axes now. We can see it goes from 0 and a big box there is all the way up to 10 meters. So what do these little boxes represent? That's what we need to figure out. Okay, so that would divide, we've got 1, 2, 3, 4, 5 little boxes. Okay, and 10 divided by 5 is 2, so let's see if that works. There's a little box going, so that is 0. Then the next little box is 2, 4, 6, 8, 10. Okay, so we figured out each little box is representing 2 meters. Okay, so we have to get all the way up to 6 meters. So that's going to be 3 little boxes. So that would be 0, 2, 4, 6 will be there. Okay, so we need to intersect these points now. Okay, so up from 4 seconds all the way up to 6 meters will be right there. Okay. Next point, 8 seconds and a distance of 14 meters. So there's 8 seconds and we want to go up to 14 meters. So there's 10, okay, and each little box on this scale represents 2. So 10, 12, 14. Okay, so it's going to be along that line and we're at 8 seconds. So we need to intersect them, which is right there. Okay, 12 seconds and 24 meters. 12 and 24, so there's 12. Okay, and bring that up to 24. So that's 20, 22, 24 is right there. Okay. Now, we need to go to 16 seconds and 44 meters. There's 16 seconds, and we need to get all the way up to 44 meters. So we're looking on our scale here. There's 40. Okay, so that would be 42. 44 would be right there. Okay, that's our point. Last point is 20 seconds and 100 meters. That's a nice easy one for us. Okay, there's 20 seconds. Bring that all the way up. And 100 meters is there. Across. It's going to be right there. Okay, next thing we need to do is we need to connect our dots. So we want to connect our dots using a nice smooth line if possible. We'll bring our thickness down to 1. Okay. Now this is not super easy to do on a computer, but it'd be much easier for you to do on your graph paper. Okay. and with a pen and pencil. So connecting our dots nice and smooth, or as smooth as possible. There. It's a bit wiggly there, but it'll do for me, okay? I would expect better from you and your work. Right then. Now, so we've used the table to draw a distance against time graph. That's done. Now we need to find the time taken for the vehicle to travel 80 meters. Okay. Now, we just have to use our graph to do this. Okay. So we need to find our distance. Where is 80 meters? Well, there it is right there. Okay. And if you're doing this on paper, I would draw a dotted line with pencil all the way across. Okay. All the way across till you hit the line, the curve that you've just drawn. Then you want to go all the way down, dotted line, you get the idea. And it's about there. And it hits our x-axis just there. And that's the midway point between 18 and 20. So it's halfway between 18 and 20. Okay, so that point right there must be 19 seconds. Okay, so that is 19 seconds. What's next? Calculate the average speed of the vehicle during the last 4 seconds of the run. Okay, so the last 4 seconds of the run is from 16 seconds all the way up to 20 seconds. Okay, that's the time interval there. Okay, so the time taken from 16 to 20 seconds is 4 seconds. Okay. And what's our distance from those times? Okay, well, it goes from this point here, which is 44 meters, because we read that. That's up there on our table as well, in case you didn't want to use your graph. And it's going all the way up to 100 meters. Okay, so what's that? This is not a very straight line. Okay, so that distance there we need to figure out. Okay. I'm going to pause it there for 1 second, and we're going to have a look at our speed equation before we go any further on the graph. So calculate the average speed of the vehicle during the last 4 seconds of the run. Okay, so if we're being asked about a speed question, you need to be thinking straight away about your speed is equal to distance divided by time formula. Distance divided by time. Okay, so in this question, we are looking for speed. That's our question mark. Do we have the distance? We'll work that out from the graph. And the time. Okay, so let's figure out what information are we given here in the question. Okay, so the time taken is from 16 seconds to 20 seconds. So that's 4 seconds. So our time we do know, that is 4 seconds. And now let's use our graph to work out the distance. Okay, so it's going from 44 meters all the way up to 100 meters. Okay, so it's going from, sorry, I'll make this big. So the distance is going from, I'm going to do this down here. Okay, so what is the distance? Okay, we're going from 44 meters during that time interval, and we're going all the way to 100 meters. So what is that distance traveled? A couple of ways to do this. Some people might say 100 minus 44. Okay, I like to do what would be 44 plus what would equal 100. Okay, same difference really. So 44 plus, it will be 56 is equal to 100 meters. So the distance traveled during that time interval is 56 meters. Okay, going from here all the way up to here. Okay, 56 meters. Okay, on our graph there. Now we have all the information we need to answer the question. So we are looking for the speed. Speed is our question mark. And it's the distance, which is 56 meters, divided by the time taken to do that distance, which is 4 seconds. Okay, so 56 divided by 4, is that 14 meters per second? Let's just double check before I leave it at that. It is indeed. Okay, now how did I know that my unit was meters per second? Okay, look up here at our question. It is 56 meters divided by seconds. Okay, so I just put my forward slash to the side here. That's the only difference. All right, now this means that the average speed is 14 meters for every second. So the car is traveling 14 meters for 1 second. It will travel 28 meters in 2 seconds. Right then, so we have calculated the average speed, and that was 14 meters per second. Now, what is the difference between speed and velocity? All right, now sometimes, and myself included, I'm a bit guilty of this. I use them almost interchangeably. Okay, now velocity has one big difference compared to speed. Velocity has direction. Okay, so velocity is speed in a given direction. Okay, so velocity could be, for example here, 14 meters north or 14 meters east or west. So that would be a direction given. Whereas with speed, has no direction given. Okay, that's the difference between speed and velocity. Right then, I hope you found this video useful, and best of luck with the rest of your questions. See you now.